Hello everyone, welcome to today's lecture. In our today's lecture, we are going to learn about the next protocol, which is a stop and wait ARQ. We already seen the stop and wait protocol. We already seen what is a ARQ in our previous lecture. So automatic repeat request is stands for ARQ. So ARQ ensures a sequence of information packet is delivered in ordered without errors or duplications despite transmission errors and loss. So that is called the ARQ. So this we already know what is a stop and wait protocol. So in stop and wait ARQ protocol, the functionality of ARQ is included in the stop and wait protocol. The basic elements of ARQs are error detection code with higher error coverage, acknowledgement, a positive acknowledgement and a negative acknowledgement, and the timeout mechanism. So these are the functionality that is provided by the ARQ, and will attach this functionality to the stop and wait protocol. Next is the characteristics of stop and wait protocol. So it is used in the connection oriented communication only. It is not used in the connectionless. It is offers error and flow control, as we are seeing the algorithm for the flow control and the error control. So this is also the one of the algorithm of error and flow control. It is used in the data link and transport layer. Stop and wait protocol lies in the data link layer. So here stop and wait ARQ protocol is used in the data link as well as in the transport layer. Stop and wait ARQ mainly implements sliding window protocol with window size 1. So we can say that this is a combination of stop and wait and sliding window protocol. In the sliding window protocol, we can send multiple packets at the same time, while in the stop and wait protocol we can use one packet at a time. So in the stop and wait ARQ, we can send or we can slide frames with the window size 1. It has only one window size and it can move only one on the frames. So this is called the stop and wait ARQ protocol with window size 1. Also we can say that it is also a sliding window protocol with the window size 1. Next, this is a Simplex protocol with sequence numbers and with acknowledgement frame indicating the sequence numbers of next frame expected. So this protocol use the packets with the sequence number, and each sequence number is written on that packet. So we can at the receiver end we can expect that if it is a received packet is 5, then the next received packet is 6. And the sliding window protocol, the maximum window size of 1, then it becomes the stop and wait ARQ. Such protocol uses stop and wait since the sender transmits a frame and waits for the acknowledgement before sending the next one. So this is a stop and wait protocol. 1 bit sliding window protocol is also called stop and wait ARQ. It is a noisy channel communication. In a noisy channel communication channel. In a noisy communication channel, if frame is damaged in transit, the receiver's hardware will detect this when it computes the checksum. If damaged frame is received, it will discard and it will be discarded, and transmitter will retransmit the same frame after receiving proper acknowledgement, or you can say that after receiving the negative acknowledgement, it retransmit to the receiver. So this is how stop and wait used. If acknowledgement frame gets lost, and data link layer on A eventually time out. So not having received an acknowledgement, it assumed that the data frame was lost and damaged and sent the frame containing packet 1 again. This duplicates frames also arrives at the data link layers on B. Thus a part of file will be duplicated and protocol is said to be failed. So duplicate is also not received at the receiver side. A typical approach to solve this problem and the provision for sequence number in the header message. So the receiver can then check for the sequence number to determine if the message is duplicate, since only message is transmitted at any time. So suppose the packet 5 is already received, and again this packet is received at the receiver end. So by just comparing the sequence number, we can make sure that this packet is duplicated or not, and if duplicated, we can discard that packet. So this is how duplication is removed. So this is a diagram of stop and wait ARQ. In the sender side, the one array is there in which the frame is there, the frame that are transmitted, that are there in the data link and in transport layer. That frame is traveled through the network and received at the receiver side and the data link layer, and then to the transport layer, and then to the application layer, and to receive. So as for showing the figure, so here this is a next frame to send. So it is a 1, it is a 0. So at the receiver, the next frame to receive is 0. So this is same like that. Here it provides a data frame with the sequence number, and also it included IP address and such things. After receiving this data packet, it sends the acknowledgement to the sender. Now the sending and receiving station needs only a 1-bit altering sequence of 0 and 1, maintaining the relationship of the transmitted message and its acknowledgement, and AK or positive or negative acknowledgement. A modular 2 numbering scheme is used when the frame is alternately labeled with 0 and 1, and positive acknowledgements are of form of acknowledgement 0 and acknowledgement 1. So this is the sequence numbering system. The next is the operations. So the sender transmits the frames, and frame arrives at the receiver. It checks for damage and acknowledges to the sender accordingly. While transmitting a frame, there can be 4 situations. The situation like 1 is a normal case, second is the frame is lost, third case is the acknowledgement is lost, and the fourth case is acknowledgement is delayed. So let's start with the first case. So this is a normal case in which we are sending one frame, it acknowledges that frames and give data to and receiver acknowledge that frames. Then the sender again slide their window of 1 to the next frame and then send this frame to the receiver, and the receiver acknowledge that one frame. So this is how this algorithm is work in the normal operation. So in normal operation, the sender sends frame 0 and waits for the acknowledgement 1. After receiving acknowledgement 1, sender sends next frame 1 and wait for the acknowledgement 0. This operation is repeated. Figure shows this operation that I already shown you. Usually a timer is set by a sender after each time each frame is transmitted. Its acknowledgement must be received before the timer expires, otherwise it will retransmit. Second is lost or damaged frame. Suppose a sender sends the new frame but that frame is lost or that frame is damaged. So in this situation, when receiver receives the frame and found it damaged or lost, it is discarded but retained in its number. When sender does not receive its acknowledgement, it retransmits the same frame, and this is reaches to the receiver. So in which the concept is same, it uses the timer. So after some timeout time, it will retransmit the frame. Third is a lost acknowledgement. The frame is reaches to the receiver, but when receiver acknowledges to that frame, the acknowledgement is lost. So in this situation, when acknowledgement is lost, the sender does not know whether the frame is received by the receiver or not. So after the time expires, the sender retransmits the same frame. So on the other hand, receiver has already received this frame earlier, hence the second copy of the frame is discarded and acknowledgement is sent to the sender. So and the last is a delay acknowledgement. So here when sender sends one frame, but it needs time to process at the receiver side, so some delay is occurred. So in that situation, if the acknowledged frame may be delayed due to some link problem, the acknowledgement is received after timer is elapsed. So while the sender has already transmitted the same frame, again second acknowledgement is initiated by the receiver for the retransmitted frame. Hence the second acknowledgement is discarded. To avoid duplication of the acknowledgement must be numbered. So acknowledgement is also numbered with the sequence number. So this is shown in the acknowledgement. So this is shown in this figure. So in this here some due to some delay, the acknowledgement is not received at the receiver sender. So sender again sends the frame, but at that time the acknowledgement is received. But sender sent that frames again. So the receiver also again sent the acknowledgement to the sender. So here sender noticed that there are two acknowledgement is received for this one same frame. So one is discarded for remove the duplication. So this is how the fourth scenario is worked. So this is all about stop and wait ARQ protocol. The next is advantages. So sender keeps a copy of last transmitted frames until the acknowledgement is received. Both data frames and acknowledgement frames are alternatively numbered as 0 and 1 for identification of frame and to avoid the duplication of frames. If it is received and getting acknowledgement, then it is 1, then the next data frame sent is 0. After 0 acknowledgement, the next data frame is 1, so it is in 1 and 0. In case of damage or loss of frames, the frames are discarded, no acknowledgement is sent. The frames are numbered sequentially to avoid duplications, and also it maintains the order. The sender maintains a timer. If acknowledgement is not received in the time, the sender assumes it's lost, and the receiver sends only a positive acknowledgement. So the next is disadvantages. So if the sender's frame is lost, the receiver never sends acknowledgement, and the sender will wait forever if there is no timer. If the receiver's acknowledgement is lost, then the same thing happen. If the acknowledgement is damaged, the sender may draw the wrong conclusion and make protocol fail. So these are the disadvantages of stop and wait protocol. So that's it about stop and wait protocol. Thank you so much for listening. Have a great day.